Okay, this is the second part to the second video for section 2.7. This is going to address a couple more key theorems, the complex conjugate theorem and the irrational conjugate theorem. And basically all this is telling you is if you happen to have a complex solution, if you know that you have a zero that's 2 minus 3i, okay, you know that's one of your zeros, then 2 plus 3i has to be another zero. They both have to be included. You can't just have one or the other. You have to have both. Same thing for the irrational. If you've got 2 plus radical 3, if you know that's a zero, then 2 minus radical 3 also has to be a zero. Okay, the conjugates have to be together. If you've got one, you're going to have the other. So for example, if I tell you that 3 minus 4i is a zero of a function, you have to tell me that you know that 3 plus 4i is also going to be a zero. You can't have one without the other. If I tell you that 2 minus radical 7 is a solution to or a zero to a polynomial or to a function, then you have to know that 2 plus radical 7 is also a zero. Okay, so hold that thought. I'm going to show you a couple examples really quick on how we can use these ideas. Okay, these ideas with the conjugates come into play with these. Okay, you're going to have some problems in your book that are going to have you write a polynomial function of at least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. So this is telling if we've got these are zeros, it's telling us these are our zeros. So like I've been telling you in class, if negative 5 is a zero, then x plus 5 has to be a factor. Okay? If negative 1 is a zero, then x plus 1 has to be a factor. If 2 is a zero, x minus 2 has to be a factor. So if all of these are factors for my function, okay, all you have to do is multiply those out and you have got a polynomial function. Okay? I'm not going to, so really quickly I can multiply this out for you. If I multiply these first two together, we get x squared plus 6x plus 5. Okay, then just like we were doing earlier in section 2, you're going to then multiply that by x minus 2, and when you do that you get x, I'm just going to go ahead and skip this, oops, it's not x cubed plus 6x squared plus 5x, and that's just multiplying the x times everything in the polynomial. I'm going to multiply negative 2 times everything, so that's going to be a negative 2x squared, and then a negative 12x, and then a negative 10. And when we combine all of our like terms, we end up getting x to the third plus 4x squared minus 7x minus 10. So that is our polynomial that has negative 5, negative 1, and 2 as zeros. Now this one is a little bit trickier, okay? This one has an imaginary number. And like I was telling you before in the previous slide, if negative 3i is a zero, then its conjugate has to be a zero. Now don't let that throw you off that it's just negative 3i. What it really is 0 minus 3i, right? So the conjugate for that is positive 3i. So if it tells you that negative 1, 2, negative 3 are zeros, you've got to include 3i. This is going to be a 4th degree polynomial. You've got to include that 3i because the complex conjugate theorem tells you that if you've got one, you've got to have its conjugate as zeros. Okay, so once you have that, then you can rewrite, write all your zeros out. So my zeros are going to be x, I'm sorry, I have my zeros. I'm going to write my factors. So x plus 1 is going to be a factor because negative 1 is a 0. X minus 2 is going to be a factor. Okay, x plus 3i is going to be a factor. Okay, and x minus 3i is going to be a factor. Okay, so now you have to multiply all of these out. This is going to be your function here. Okay, and when you do that, this one's pretty easy. You know how to FOIL this stuff out. So this is going to be x squared minus x minus 2. Okay, that is this part. Okay, now I'm going to multiply this out. We're going to have x squared. Our inners and our outers are going to cancel out. I'm going to end up with a plus 9i squared. Now remember about imaginary numbers, I squared is a negative 1. I'm sorry, this isn't a negative. Ooh, that's a negative right there. Because a positive times a negative is negative. I'm jumping the gun here. But because this right here, I squared is a negative 1, you end up getting x squared plus 9. Because this right here is a negative 1. So negative 1 times a negative 9 is a positive 9. So now we've got x squared minus x minus 2. And you can multiply this out. You got to do x times everything, 9 times everything. So just like we did with this problem over here, you've got to distribute, let me use the black here, distribute the x squared. So when I do that, I get x to the 4th, shoot, here we go, x to the 4th, minus x to the 3rd, minus 2x squared. And that was just me multiplying this x times everything. Okay, and then we got to do the same thing with the 9. So that's going to be a 9x squared, negative 9x, minus 18. Okay, that was 9 times 2, 9 times x, 9 times x squared. That's what that is. And then when I combine all of my like terms, we get x to the 4th minus x to the 3rd minus 7x squared minus 9x minus 18. And that is our function. Voila. So in your homework problems, you're going to be asked to do some of these, a few of these problems. So you're going to be doing a little multiplication, and you have to understand your conjugate and your complex conjugate and your irrational conjugate theorem that we have here on this previous page. Let me go back there, show it to you one more time. The irrational conjugate theorem and the complex conjugate theorem. Okay, good luck.